Hello students, so the first chapter, that is some basic concepts of chemistry, that chapter is over. There are two more topics were there in this particular chapter. It's about the concentration of the solutions, certain how we can measure the concentration of the solutions. That topic was there in this chapter, but CBSE has revised your syllabus. So according to the CBSE, because of the current situation, we are not getting our academic year. We have missed a lot of days. So we are not able to come to the school also for that because of this current pandemic situation. What the CBSE has done means they have cut short your syllabus. So by that, your first chapter till what I have taught, till the stoichiometry of the chemical reactions and the last one, limiting reagent, till that it will be there for your from your first chapter. Other than the concentration of the solution, that topic is removed from this particular chapter by the CBSE. But that particular topic, if it is needed for your entrance classes, for the entrance purposes, that topic will be described to you by Irsha sir while he is taking entrance classes. Okay, so thereby we came to the end of the first chapters. Today we will be going to start with the second chapter, that is the atomic structure. Okay, so the first chapter is over, so you need to study properly. You will be having one unit test for that particular chapter also. I will send the link. It will be through the Google form itself. I will send the link in your WhatsApp group also. So today we are going to start with the second chapter, that is the atomic structure. Okay, so you have studied something about the atomic structures in your lower grades. You know that you know that matter. We have started with the matter, right? What is a matter? You know that anything that occupies the space and has a definite mass, we call them as a matter. Okay, from the earlier days itself, from the long years before, from there on was the Indian philosophers or the Greek philosophers. They were started researching on what is this matter made up of. How does a matter composed of? What is the building block of this matter? How does this matter is a building up of? Okay, so lot of researches were going on. With the lot of researchers, they came to a conclusion that matter is made up of atoms. So they told that atoms are the indivisible particles. We cannot divide the atoms anymore. Okay, they thought that atoms are the finest particle if we will get when we divide the matter into smaller particles. Likewise, when we start dividing a particular matter, we are divided into many tiny particles. Then we will reach the last point. That particular point, from there we cannot divide the matter anymore. That particular point they have called as the atoms. But the thing is that at that time the science were not developed like this. So they thought that atoms are the indivisible particle. That is the last part of a matter. But soon when the science is progressing, we came to know that atoms can be divided into smaller particles. So we call them as the subatomic particles. So in your 9th standard, you have studied about the subatomic particles too, right? We have protons, we have neutrons, we have electrons also. So these are the three main subatomic particles that we have studied. Okay, electrons, we have studied that electrons are negatively charged particles in an atom. Then protons also we have studied. Protons are the positively charged particles of an atom. Then we have the neutrons also, right? Neutrons are the neutrally charged particles, right? Then we have studied about where do these subatomic particles are existing, right? We have studied about the Rutherford scattering model. Hope you remember it. Gold foil experiment conducted by the Rutherford. So after conducting that experiment, he came to know that an atom will be he gave somewhat idea about what is the structure of an atom. So in the middle we have one nucleus, right? In the nucleus, which all particles are there? We have the protons present over there and we have neutrons present over there. And what do these electrons be situated? What is these electrons are doing? These electrons are revolving around the nucleus, right? They are revolving around the nucleus. right? We have studied something more about the atoms, right? We know that atoms, different elements are there, different molecules are there. An atom contains some protons in it, some electrons present in it. So the number of protons or the electron present in an atom, we call them as the atomic number, right? We call them as the atomic number. Then we have studied the mass number also, right? What was the mass number? We have studied the mass number means total number of protons and neutrons present in an atom. We call as the mass number also, right? So each element will have a particular atomic number depending upon the number of protons or electrons present. Most probably we are saying that the number of protons itself, right? We know that elements can produce ions also. What was ions, right? To remember everything, ions are the charged species, right? So first thing what you need to do is you take the chapter of structure of an atom in the 9th standard, just have it go through it. Okay? Again, I told you that CBSE has revised their syllabus, so the first part of the structure of atom, that entire part is removed from our syllabus. But again, I am telling you that may be required for your entrance. So Irshad sir may be describing it while he is taking the entrance classes. Okay. So suppose this is your chemistry textbook. We are starting with the structure of atom. So in the structure of atom, again a lot of topics are the subatomic particles, electrons, how does the electrons are discovered, all those topics are removed. What is the charge of the electron? How does Rutherford's nuclear model of atom? We have studied about the J.J. Thomson model of atom, right? Do you remember it? Plum pudding model, right? All those topics were removed. Then we have isobars, isotope. These are some basic things that you need to know about an atom. Okay. Then developments leading to the Bohr model of atom. We are again Planck's quantum theory. These all topics are removed. So we are starting from according to your syllabus, we are starting from the Bohr model of an atom. Bohr model of an atom. That's on this page number 42. So we are starting with the Bohr model of an atom. It's page number 42. From there onwards, we are starting it. What is a Bohr model of an atom? Okay. So again, we have studied that, we have discovered about the atoms. Now we know that atoms are present. Now we know that nucleus is present at the center and the electrons are revolving around. But we should know exactly what is the structure of an atom and where do these protons are existing, where do these electrons are existing, what do these neutrons, electrons and protons are doing. So for that we have studied a lot of atomic models also. We have studied about the J.J. Thomson model. We have studied about the Rutherford's model, right? Then such that lot of atoms were made to find out the structure of an atom. Lot of atoms were made. Okay. The last one, so Rutherford's model and the J.J. Thomson's model we have already studied. So in this year we are starting with the Bohr model of an atom. Niels Bohr. Niels Bohr, he has proposed a particular structure for an atom. What is this idea about the structure of an atom? So that's what we are studying in this particular unit. So what, as I told you, the initial part of this chapter is removed from the CBSE syllabus for this academic year only. But while you are taking the entrance classes, Ishasa may be describing it to you. Don't get tensed. It won't be asked for your examination when we are conducting the midterm examination, pre-midterm exam. For your annual examination, we won't be considering these topics because it is removed from your CBSE. We are strictly following the CBSE syllabus only. So I will be uploading the syllabus also in this video, so you can have a go through it, which all topics are included in this chapter. Okay. So let's watch about it. Let's have a very quick revision of what is an atom, what is protons, neutrons, electrons and all. Okay. So study it properly. If you are having any doubts, contact me. Okay.
atoms. What is an atom? What makes up an atom? Oh, what is the structure of the atom? What are the subatomic particles? Let us look at what all these things are. So the first question is, what is an atom? So atom is the smallest particle, it is indivisible particle that is existing on an matter. So atom is the smallest particle of a chemical element that can exist. So atoms are very small. What makes up an atom? Atoms are made up of very smaller particles. We call them as the subatomic particles. So there are mainly three subatomic particles: neutron, electron and proton. What is the structure of an atom is? So atom has a nucleus at the center and the electrons revolving around it. Electrons in the center we have nucleus. Nucleus contains neutrons and protons. Neutrons are neutrally charged, protons are positively charged and electrons are negatively charged. So these particles, we call them as the subatomic particles. So let us discuss about the mass and electrical charge of the proton, neutron and electron. Proton charge is +1, neutron has no charge and electron has a negative charge. We are approximating the mass of the proton as 1 and the neutron's mass as 1 and the electron's mass almost 0. This is just the approximation. It's not the accurate masses. Accurate masses we will study in this chapter. How can we represent an symbol of an element? Suppose carbon, its atomic number is written at the bottom and mass number is written on the top of it. So element symbol is written at the middle. 6 is the atomic number. So it is equal to the number of protons and electrons. Mass number is which is written on the top of the element. We call it as atomic weight, or we say it is as a mass number itself is the number of protons plus number of neutrons. Hence, mass number minus atomic number will give you the number of neutrons.
Atoms make up everything. But what makes up atoms? Protons, electrons, and neutrons. There are 118 different kinds of atoms, which are each the smallest part of an element. If we observe elements like gold, carbon, and oxygen, we can see that they have very different properties that don't look or act the same. But why are they so different? Well, it comes down to what's inside their atoms. As you can see here, atoms are made of just 3 types of tiny particles called protons, electrons, and neutrons. And each of these tiny particles does something special. For example, it's the number of protons inside an atom that makes each element different. If we look at the periodic table, the first element, hydrogen, has 1 proton. The second element, helium, has 2 protons. And the third element, lithium, has 3 protons. This goes on all the way up to the 118th element, oganesson, which has, that's right, 118 protons in its nucleus. By the way, the number of protons in an atom is also called its atomic number, which you can see here on the periodic table of elements. Now, electrons are much smaller than protons, and they zip around protons at lightning speed, making up something called an electron cloud around the atom. Electrons do this because they have a negative electrical charge, which always pulls towards the proton's positive electrical charge. This pull between the positive protons and the negative electrons is called the electric force, and it's always there. So whenever a free electron gets close enough to a lonely proton, zap, they'll become part of the same atom. That's why all the elements have the same number of electrons and protons. So why do atoms need neutrons? Well, without neutrons, the electric force will cause the positively charged protons to push each other out of the atom. But there's a stronger force that exists between neutrons and protons, which stops the protons from flying apart. It's called the strong nuclear force, or strong force for short, and it kind of works like glue to hold the nucleus together. If there were no neutrons, everything would simply be hydrogen.
So let us learn about the atomic structure of hydrogen atom, which is put forward by the great scientist known as Niels Bohr. So Niels Bohr on 1913 has given a satisfactory explanation for the atomic structure of hydrogen as well as its spectrum also. What is a spectrum? Spectrum is a series of radiation that is emitted by an atom, molecule, or an ion. So what will happen means sometimes suppose an energy is given out. Suppose an atom or a molecule is absorbing the energy. The electrons present in that atom can move to a higher energy level. It is absorbing the energy. So it is moved from a lower energy level to a higher energy level. But higher energy level means it is not at all stable over there. So what will happen means it will come back to its lower energy level by giving out or emitting out certain radiations. Certain photons will be emitted out from it. That emission, we call it as a spectrum. So Neil Bohr has given a satisfactory explanation for the atomic structure of hydrogen as well as its spectrum also. So let us study about what are the main postulates. What are the main postulates that is given by the Neil Bohr about the atomic structure of hydrogen atom. So, what all things that Neil Bohr has considered for proposing the atomic model of the hydrogen atom? Okay. So, postulates of Bohr atomic model mainly includes motion of electrons in a stationary orbit. That is, how does electrons are moving around in an orbit? Next, he has explained about the fixed energy of the electrons which is revolving around an orbit. Then, what is the energy change that happens during the transition of electrons? When the electrons are getting transition from one orbit to another, what is the energy change that occurs over here? He also explained about the fixed angular momentum of electrons. Angular momentum of electrons. So these are the four main areas he has explained in its atomic model of hydrogen atom. So the first postulate in Bohr model of hydrogen atom states that the electrons in the hydrogen atom are moves around the nucleus in a circular path of fixed radius and energy. So these paths we call it as the orbits. Okay, so motion of the electrons are taking place in a stationary orbit which is are having fixed radius and energy. Okay, so these orbits are arranged concentrically around the nucleus. So these orbits are arranged concentrically around the nucleus. These orbits are also known as stationary states or allowed energy states. Stationary states or allowed energy states. Now, how does these electrons are revolving only in the concentric circles known as orbits? It is because of the electrostatic force which is exerted by the nucleus on the electrons. So, between the electrons and the nucleus, there is an electrostatic force which will help the electrons to stay in the stationary orbit itself. So next is fixed energy of electrons. So Neil Bohr has told that energy of an electron in an orbit is fixed. It won't change at all. So each electron present in a particular orbit will be having the same constant fixed energy. Its energy won't be changing unless if it is absorbing energy. If an electron is absorbs energy, it will get promoted to the higher energy level. There the electrons will have more energies. Okay, so the electrons, if it is accepting the energy or if it is no absorbing the radiation, it will be promoted to the higher energy level where the electrons will be having more energy. Otherwise, this electron should emit out. It should give out the energy. It should emit out the radiations. So what will happen? It will come back to the lower energy level. Okay. So each electron of a particular orbit will have a particular energy only. Okay. So we can measure the energy change, the delta E, by subtracting the higher energy with the lower energy. higher energy, we can measure it as EF. Lower energy, we can measure it as the EI. So we can measure delta E is equal to EF minus EI. Okay, so we'll get the energy difference. So the third postulates of Bohr's atomic model states about the energy change during the transition of electrons. As I told you, transition of electrons means jumping of one electron from one orbital to another. Okay, from one orbit to another, electrons are getting jumped, right? So that jump we call it as a transition. In the second postulate, he has explained that energy of the electron in a orbit is fixed unless this electron has undergoing transition means jumping from one orbit to another. So this transition will occur only if the electron is absorbing the radiation or if it is emitting a particular radiation. So emission or the absorption of the radiation will result in the transition of electrons. Okay, so in the third law, third postulate, he states that the frequency of the radiation absorbed or emitted when transition occurs between two orbits or the two stationary states, so that differ in an energy by delta E. We are told that delta E is the energy change. So that frequency is equal to delta E by H. What is delta E? E2 minus E1. That is the two stationary states or two orbits, energy of the two orbits, that divided by h. H is the Planck's constant. So h is the Planck's constant. This will give you the frequency of the radiation absorbed or emitted. So when an electron is undergoing transition. So nu is equal to frequency nu is equal to delta E by H, where delta is the E2 minus E1, where H is known as the Planck's constant. So what is the value of Planck's constant is 6.626 into 10 raised to minus 34 joule second. So Planck's constant is a constant value. It has a value of 6.626 into 10 raised to minus 34 joule seconds. So, the fourth postulate of Bohr's atomic model told about the angular momentum of the electrons. So, the electrons which is moving around in a particular stationary state has an angular momentum. So, this angular momentum is given by the relation me into v into r, where me is the mass of the electron into v is the velocity and r is the radius of the whichever that orbital that it is revolving. So this angular momentum is equal n into h by 2 pi, n into h by 2 pi. Okay, so mvr angular momentum is equal to nh by 2 pi, where n is equal to, n has a value of 1, 2 or 3 depending upon which orbit in which the electrons are revolving, whether it is in the first orbit, second orbit or the third orbit. Depending upon that, n is having a values from 1, 2 or 3. So since this electrons can move only in those orbits for which it is having a fixed angular momentum, right? So this angular momentum Since this angular momentum is an integral multiple of h by 2 pi, so these electrons are allowed to move only in a fixed orbits. Okay, so the electron can move only in those orbits for which its angular momentum is integral multiple of h by 2 pi. So that is why now only these electrons are moving only in a certain fixed orbits. Okay, so the angular momentum of the electron in a given stationary state is given by the equation mvr is equal to nh by 2 pi. So these are the basic postulates of the Bohr's model for hydrogen atom. So in the next class we will study further much more detail about the Bohr's model of hydrogen atom. Okay, I hope you understood the main four postulates of the Bohr's model.